Hello, I'm very glad to see you and share our team's work, this time at CLI. My name is Tian, a third-year PG student majoring in information science at CU Boulder. I'd also like to introduce my collaborators, Emily, Laurel, Paul, and Gregory from CU Anschutz, and Sriram, Casey, and Steve, my advisor from CU Boulder. I will present our paper, How Adolescents and Young Adults Infrastructure Resources to Learn Type 1 Diabetes Management. Type 1 diabetes, which is T1D, is characterized by inadequate endogenous insulin production, resulting in persistent hyperglycemia or high blood glucose levels and life-threatening hypoglycemia or low blood glucose levels. T1D is also recognized as among the most psychologically and behaviorally intricate of all chronic medical conditions. Managing the condition involves attending to and exerting control over multiple aspects of personal life, such as diet and activity, all of which can impact blood glucose fluctuations. Type 1 diabetes is most commonly diagnosed in young people, especially during adolescence or youth, displaying a notable rise. However, adolescents and young adults aged 15 to 25, their self-management levels notably lag behind other age groups, often resulting in severe consequences like hospitalization and diabetic ketoacidosis. This could be resulted from unique challenges by adolescents and young adults, such as life transitions, social, psychological, and physiological factors impacting T1D self-management. As such, self-management practices significantly influence T1D treatment outcomes. It has been reported that individuals are responsible for 95% of lifelong diabetes management, including maintaining vigilance over glucose levels, regular administration of doses of insulin to offset blood glucose increases caused by meals, and making adjustments for hypoglycemia or hyperglycemia. Hybrid closed-loop insulin pump systems, also called HCL systems, are rapidly evolving context-aware diabetes technology. HCL systems can alleviate much of the management burden for young people by combining continuous glucose monitors, insulin pumps, mobile applications, alerts, and predictive algorithms that automatically adjust and suspend insulin delivery. Adolescents and young adults experience a critical learning stage of personalized self-management routines. When encountering unpredictable events, uncertainties, or unique challenges in everyday life, they have to adapt, adjust, and perform daily self-care practices. They do this with the help of awareness support from HCL systems and lived experiences, cues such as bodily cues and self-experiences. However, both awareness support resources can have disruptions and breakdowns, such as alarm fatigue in technical systems and non-routine things occurring in everyday life. So we ask, how do adolescents and young adults infrastructure their resources, which is situational awareness, to learn type 1 diabetes self-management routines in both technological and non-technological contexts? In this study, we recruited 20 participants aged 15 to 25 with T1D and using HCL systems. Participants first completed a user-initiated real-time survey each time they interacted with the insulin pump for a period of 2 weeks. The surveys were designed to collect data on what prompted the user to interact with their pump. This survey serves as a memory cue and a chance to reflect on everyday management. We then conducted interviews to understand their diabetes management experience. For example, major topics include self-management routines, with HCl systems, disruptions impacted the management routines and the reasons for checking and managing blood glucose. After collecting data, we use systematic analysis to synthesize two main themes on maintaining situational awareness for self-management. We found that adolescents and young adults maintain diabetes awareness without and with technology. First, we found that young participants maintain diabetes awareness through embodied manifestations, objective food information, and self-reflective patterns. I only have time to go into a couple of these here, and I encourage you to go to the paper for the rest. Take embodied manifestation for example. Our participants share the bodily feelings of shakiness, nausea, sweating, dizziness, and headache. These embodied signals can direct them to check insulin pumps and take actions for proactive treatment. For example, Peter shares that I might check my blood sugar on the insulin pump if I was feeling particularly nauseous or shaky or something. P12 shared that I just get a little shaky, and that's about it. I generally catch it before anything happens. This finding indicates that young participants use embodied manifestations as a part of their health infrastructure, shedding light on the potential mechanisms underlying improved glucose control through situational awareness-supported proactive treatment. The second theme is with technology. We identified three patterns here. Specifically, young participants maintain diabetes awareness through data awareness, nudging, and algorithmic predictions. For example, algorithm-supported awareness of near-future blood glucose levels is often used to learn when and how to proactively engage in treatment or rely on automated insulin treatment. However, some participants expressed concerns about the speed and the correctness of these algorithms. For example, P8 shares that, and I know that control IQ, at least my understanding, is that it slowly, gradually corrects me down. And so that's why I did the 5 grams manual correction bolus. It's because I know it will do it eventually. As such, the algorithm's efficacy for AI-supported healthcare may be a patient-specific question. We recommend that subsequent research consider incorporating additional kinds of contextual information. For example, self-reflective patterns and biological indicators for personalized glucose predictions to enhance algorithmic systems. Our findings highlight how adolescents and young adults with T1D use a combination of technological and non-technological resources to learn self-management routines, including self-awareness signaled by subjective information, including embodied manifestations and self-reflective patterns, and externalized awareness signaled by objective information, including food information, data awareness, nudges, and algorithmic prediction. In our paper, we discuss how adolescents and young adults infrastructure these various technological and non-technological resources to learn diabetes self-management routines embedded in specific practices, including medical treatment, diet, and glucose monitoring routines for the purpose of optimal glycemic control. Our study has several major contributions to the HCI community. First, we uncover diverse situational awareness in T1D self-management. We also highlight adolescents and young adults infrastructuring practices for learning self-management routines. We offer nuanced insights into contextualized diabetes management. We also inform future context-aware diabetes technology design. Thank you for listening. Finally, we'd like to thank our participants for their generous and invaluable insights. We also thank NIDDK and NIH for supporting our research.